Hello everyone, this is Varun Kumar Reja, and today I am presenting about existing challenges in computer vision based progress monitoring of construction projects. I am a joint doctoral candidate from IIT Madras and University of Technology Sydney. I am being guided by Professor Koshi Varghese at IIT Madras and Professor Kwang Ha at UTS. So project management is actually three-step cycle: planning, monitoring, and control, where we are focusing currently on monitoring stage. In monitoring stage, the progress of the project needs to be monitored effectively, and to monitor that, we need the as-built status from the project, which is a challenging task. This as-built model has to be compared with the as-planned model to have a effective control strategies on the projects. So if this monitoring task is not fulfilled correctly, the cycle get compromised and we lose the control of the. So we start with the literature review where I categorize the paper into what kind of technologies they have used for progress monitoring, what kind of algorithms they have used, and on what stage they have classified the progress, whether they have integrated BIM or not, and what is the modeling techniques. So after this literature review, I came to a conclusion that there are in the computer vision based progress monitoring, there are three steps. The first step is data acquisition and 3D reconstruction. So there can be multiple technologies used for data acquisition and 3D reconstruction. As you can see, drones, handheld devices, cameras, laser scanners, fixed cameras, tablets, many devices can be used. Second is as-built modeling. The second step of is as-built modeling, where when you after capturing the data, we make a as-built model from these images or point clouds, and we convert it into either point clouds, mesh models, surface models, voxel models, or IFC models, which is the highest class of defining, where you can represent a model in form of objects. Final step is progress estimation, where we compare the as planned and as built progress, and it can be seen as shown in this study. So the first challenge is to decide which device are to be used for effective progress monitoring. So these devices are based on these vary based on cost, mobility, training requirements, specifications, level of automation, etc. So we come to the challenges of vision-based progress monitoring. First of all, the data capture. It is affected by weather issues. Now, the weather issues can be rain, fog, mist, dust. This affects the visibility of the data. Hence, uh, all the vision-based devices are affected by these kind of issues. So one first issue is this. Second issue is navigation issues. In construction site, there are a lot of unwanted project objects that are present there. They are very what we can say haphazard sites. So generally, the navigation for robots or UAVs, it's very much difficult. Secondly, there are the light is not adequate because of many reasons. And finally, the navigation constraints. If it is a very small area or a very underground space, the navigation is the issue. Thirdly, the cost of the technology. Laser scanning and photogrammetry, if you see the head-on comparison showed by this study, that the cost of a laser scanner is around 1 lakh euro, and for photogrammetry it is around 10,000 euro, which is very much to get implemented. And similarly, if you want a high accuracy, laser scanner give you a high accuracy, but the thing is the cost is very much, and therefore these technologies are not getting adopted highly in construction. On the second hand, photogrammetry has low cost, but the thing is the results are not as good as a laser scanner. Now, coming to what is the core issue of progress monitoring, how progress monitoring happens. We collect data using laser scanner or photogrammetry. We use the point cloud data and do some pre-processing. Then we detect objects from the point cloud data and convert those objects to a as-BIM model, which is the IFC class of data. Now, the thing is, this total progress is known as scan to BIM process. In this process, the major challenge is that Okay, so here I have a representation of scan to BIM process showing a segmented point cloud and finally the BIM development. Okay, so we have the data acquisition devices are laser scanner and depth sensor, and data digital modeling can be done through many methods. The manual methods is generally time consuming and it's tedious process. Therefore, we need automation. So the conventional scan to BIM, it's like you have a point cloud and then you manually draw walls, beams, floors, etc. And then you get a final BIM output. This is very time consuming, less accurate, manually labor intensive, requires tool sets and domain knowledge, and therefore cannot be used. The second method of converting a point cloud to a as-built model is a heuristic-based techniques, where a point cloud is there and then we use geometrical constraints to detect elements from here. So these geometrical constraints have to be coded. For example, to detect this column, we need to feed in the dimensions of the column which we are expecting to get detected, and then it gives us uh, how many number of columns has been completed or not. Finally comes the learning based techniques, which we are moving towards that. Learning based techniques see the geometry as points, and then they, based on these features of the points, they classify the element. So the challenges for a learning based techniques are that it is extensive data required for point cloud training. There are unique elements, hence it is difficult to get training data for all elements. It is highly computational to process large data, and each project is different. So there will be the type of elements which are being used may keep changing, and open sourcing and benchmarking is still not available. So these are the key challenges for learning-based methods. So finally, this is a comparison with conventional techniques, heuristics, and learning-based. That conventional are time-taking and manually intensive. Heuristics require too much information to be fed prior and domain knowledge, and learning-based techniques are less explored, requires mid-construction data for training, and requires efficient architectures for object detection and labeling. So with this, I complete my presentation, and these were the challenges which are there currently existing in for vision-based progress monitoring of construction projects.